in the biological system, unless ATP hydrolyzes, a biochemical reaction don't take place. Similarly, if nobody makes money, then nothing will be made. Right? So how do you balance the two? So I came to Delhi with a single dream 13 years back from Bangalore University of Science, where I thought of science is a way of personal growth. And how do you build a career? How do you get world-class science? How do you write a paper? How do you get the next award? How do you get the next publication and the next grant? It was in mid-90s. I was telling on my way to Vinod that I was interested in thalassemia. And I was thinking of looking at biological system mutation to understand certain protein function. And since I was interested in genomics, I was a member of the Hugo, but I was very, very interested in writing a paper. But I was not thinking of solving the problem. So I went to Calcutta, where I was born, and went to Ramakrishna Mission Hospital, where I was born, and then I saw a lab where they are actually looking at and screening patients. And they were using old technique, some paper chromatography approach. So I realized that I have the PCR, I can design oligo, I can do this, I can do that. I have the first sequencer in India, automatic sequencer, and why can't we use this? So although I went with an objective to do discovery, to write a paper, my mind changed, seeing the suffering of the patients and the mothers who brought those children who are thalassemia. I felt all my knowledge is useless if it cannot be used. So I decided to dedicate 20% of my automated DNA sequencing facility to thalassemia screening and decided to develop primers and standardize PCR so that the disease can be detected in the carrier. And many of you know that if you are a mother is a carrier, father is a carrier, both if get married and have children, there is a 50% chance, 25% chance they will have a diseased child and 50% chance they will have a carrier. Therefore, if you don't marry, and the best example is a state, Cyprus, which is a Christian state, where abortion is not recommended, who decided to do this screening and who are completely free of thalassemia. So I was very keen that this needs to be done. And that small lab, 100 square feet, go in a stool. I come from Indian Institute of Science, big institute, big professor, big awards, big recognitions. So I used to go there, sit there, to the student, and eventually established. And several years back, I went back, and I saw there are 16 photographs of children face. These are the children who were born out of the prenatal analysis without the disease, although their parents were both carriers. And that made me feel very happy. And I think I had more happiness than the papers I wrote in PNAS or JBC or JAX. With that mind in 96, I heard Dr. Abdul Kalam. And I realized that it is possible through the government system to do something very big. So I came to CSIR with a dream to establish genomics and bioinformatics in India as a utilizable tool and use to provide the next generation healthcare. As I said, you get motivated by a leader, and then that motivation works like a chain. Then you have to have a disciple, and then disciple picks it up and takes it further when you have gone. And that's the way history tells you. So it was Mitali Mukherjee who got Bhatnagar Award this year, and Debashish Dash, the bioinformatics champion, who didn't have much experience in bioinformatics when he joined me in 1998, who built up the CBT to IGIB. So when I was finishing that work, Indian genome variation, I realized that this has happened. Now bioinformatics is a discipline of science in which India is a dominant player. Genomics is a discipline of science in which we have made significant play. What is next? I felt that 1998, the sequencing has been done for the human, when we had, I want to do, I looked at what is that disease that we can tackle. And tuberculosis came out obvious because 1,000 people die every day. 5,000 in India, 5,000 will die in the world. No army, not even the most mightiest army of the United States, can stop that. It is in the hand of few thousand scientists who can make a difference. I was also fortunate to be associated with AstraZeneca's development, and I saw, in spite of 25 years, 70 scientists, $9 to $10 million per annum effort, still they could not create a new drug, completely new, for the tuberculosis. So I realized there is something somewhere wrong, and we are approaching the problem differently. So why I said we are approaching the problem differently? Because of this. Somewhere, if you look at Alexander Fleming, never patented penicillin. Louis Pasteur, for whom we all take the pasteurized milk, didn't patent it. The only disease that we have got rid of completely, smallpox, the vaccine, is generic. So anything, this world, somewhere something went wrong, and we got into a route where we started putting a strong fence, the way you put around an expensive factory. Imagine all Kerala's paddy field, you start putting electrical fence. What would be the cost of rice? Will it work? No. What do? You put a scarecrow. And this is the human genome sequencing learning. People originally thought they'll patent it. Then they figured out it is too expensive to patent. And what level you will patent? You level the DNA sequence, RNA sequence, expression profile, proteomics, protein level. You will patent. Therefore, it is best to give it open. So the whole world has given the entire human genome open. The second learning, that entire Linex has worked with the young people. So what is that AstraZeneca, the Bangalore does not have, whereas what I have? And I realized whether it is AstraZeneca, it is Pfizer, it is Smith & Nephew, it is Bristol Myers Squibb, it is everybody, they do not have 22 to 32 years age group doing research for them. They have them as technicians who are working like a robot with machine and the codified. They are doing routine screening, but they are not thinking.